All right, so this is a video on the classification of matter. Let me get my tools ready. Yep, all right, so the essential standard is understand types, properties, and structure of matter. The learning objective for this lesson is to be able to classify matter as homogeneous, heterogeneous, pure substance, or mixture, element or compound, metals, nonmetals, or metalloids, solution, colloid, or suspension. All right, so by the end of this lesson, you should be able to say with confidence that you can classify all matter as either a pure substance or a mixture, distinguish between elements and compounds, distinguish between homogeneous mixtures and heterogeneous mixtures, and explain the difference between a suspension and a colloid. All right, so when we're talking about matter, matter is anything that has mass and takes up space, right? And all matter is made up of atoms, right? So to be able to be matter, it has to be made up of atoms. And so when you look out into space and you see just the black, that's usually a vacuum. There's no atoms present, right? So where you see the stars and the planets and the nebulas and all of that, that is made up of atoms. That's what matter is. Okay. And atoms are the smallest particles of matter. If we break down matter to where you can't break it down any smaller, you would be left with an atom. All right. So what is a pure substance? A pure substance is any sample of matter that has a fixed composition, right? And substances can either be elements or compounds, right? That's all they can be. So any sample of matter that's a pure substance, well, it will always be the same, no matter what sample you get of that. So if you get some copper wire and it's pure copper wire, all the atoms will be copper atoms, no matter what. It's going to be exactly the same. If you get, for compound, carbon dioxide, dry ice is made up of frozen carbon dioxide. It's always going to have just carbon and oxygen in a 1:2 ratio. All right. So again, pure substances are made up of elements and compounds. All right. So elements are substances in which all the atoms are the same. All right. So if you had a sample of pure gold, all the atoms would be gold atoms. Right. If you had a sample of pure copper, all the atoms would be copper atoms. Right now, atoms can also be defined as being the smallest particle of an element that still retains the properties of that element. Right, so here we see a picture of silicon atoms. Now, we can't see atoms with our eyes, they're too small, but we can see them with an electron microscope. Right, so these electron microscopes are very expensive, and of course, we don't have one at the school. They have some at the universities, but in research labs. But most people don't ever really get to look at that silicon atom, right? But that is what they look like. All right, so on the photo to the right shows you a sample of silicon atom, right? So a sample of silicons, rather. Now that sample is made up of trillions and trillions of silicon atoms, right? And since it's a pure sample, if you were to break that down into the smallest piece possible, that you would be left with a silicon atom. All right. So of the elements, there are 92 that are natural elements found on Earth. Okay, and by natural, we mean that they're made through natural means. They're made inside stars. And so on the periodic table that lists all of the elements, if you look at the periodic table and you go all the way down to number 92, that's uranium. All right, so all the elements 92 and smaller, atomic number 92 and smaller, are naturally made within stars. Right, the elements larger than 92, say like let's see, Americus, which is in your the little things that buzz when there's a fire, the smoke alarms. Okay, that is made in a lab. They're synthetic atoms, and they make them by bombarding the atoms together, and they stick together to form a new atom. Okay, they usually don't last very long. and they're usually pretty radioactive, meaning that they fall apart. They give off particles and they fall apart. Okay. All right. Now, of elements, elements are represented on the periodic table with a chemical symbol. So you always know something's an element if it has a chemical symbol, right? And so with the chemical symbols, they're based on their Latin names. And so that's why, like, lead is an easy one to look for at PB. That means plumbum. Its Latin name is plumbum. And that's because in Rome, which spoke Latin, they used lead plumbing. And so that's why they called it plumbum. All right. Now, for each chemical symbol, there's a capital letter, and sometimes there's a lowercase letter. All right. So usually, when there's capital letters used, the same capital letters used more than once, that's when you'll have the lowercase letter. So for hydrogen, it's using the capital letter. Helium is atomic number 2, and so it uses a lowercase h with it. All right. Now, compounds. Right, so elements, all the atoms were the same, but in compounds, it's made up of 2 or more elements chemically combined. Right, so for sodium chloride, which is NaCl, it's made up of sodium atoms and chlorine atoms. And this chemical formula tells a ratio that for every sodium atom, there's 1 chlorine atom within any sample of sodium chloride that you look at. Okay, so chemical formulas. You can always tell if something's a compound because it will have a chemical formula, right? And the chemical formula tells you a ratio of the atoms within that chemical formula. Okay, so for pure aspirin, right? So we're not talking Tylenol or anything, we're talking pure aspirin. The chemical formula is C9H8O4. Okay, and that's telling you that for every 9 carbons, there are 8 hydrogen atoms and 4 oxygen atoms. Right, so for any sample of pure aspirin that you look at, you will always find that ratio of carbon to hydrogen to oxygen. Right, okay, so just to recap, pure substances are made up of elements and compounds. Right, elements, all the atoms are the same and they're represented by a chemical symbol, which you can find them on the periodic table. Compounds are represented by a chemical formula. So anytime you see a chemical formula, you know it's a compound. All right, now one thing about compounds, once they chemically combine, the properties of the compounds are different than the properties of the individual substances. For example, sodium as an element is poisonous, and it's also it ignites, it becomes explosive when exposed to water. If you put sodium in water, it will explode. And I'll show you some videos later on about with that people doing that. Chlorine is a poisonous gas that they used during World War I and II. When they're throwing out tear gas, a lot of times it has chlorine in it, right? So these 2 elements singularly would kill us, but when after they chemically combine, something happens to the elements that they're no longer lethal to us. In fact, it becomes non-poisonous, and not only that, but essential to life. We have to have, all animals have to have salt in order to survive, in order for our muscles and our nerves to work, right? Okay, so keep that in mind about compounds, is that the individual substances, the elements, properties are different once they're in the compound. That's not true of mixtures. Okay, now because compounds are chemically combined, in order to separate them, it also has to involve a chemical reaction. For example, salt. If we want to separate the sodium and the chlorine, it involves a chemical reaction. Right, and so here's a factory where they actually do this, and what they're trying to make is chlorine gas. So what they do is they take the salt, they dissolve it in water, right, and that's not the chemical reaction, that's just physical. They dissolve it in water, and then they add electricity. The electricity sparks the chemical reaction, and that'll separate the sodium and chlorine from each other so that the sodium will bond with an oxygen and hydrogen from the water to form sodium hydroxide. And then you get hydrogen gas, which they just vent out into the atmosphere. and you end up with chlorine gas, which they can collect and use for commercial reasons. All right, so now we're on to mixtures. Right, so mixtures are a combination of two or more substances that are not chemically bonded together. They're just mixed together. Like when you make a pizza and you're just adding those ingredients, you're not chemically combining those mushrooms with the black olives, you're just mixing them together. Soda is another mixture. We're just mixing carbon dioxide gas, syrup, and water. Or here you see a density graduated cylinder with different substances, and they're just mixed together, but they separated themselves out by their density. Right, so because mixtures are not chemically combined, it doesn't take a chemical reaction to separate them. For example, here we have some sulfur with iron, and you can just run a magnet through it and separate out the iron. Or here they're sifting. We often separate things out by size. Um, and that's just a physical way to separate a mixture. Okay, so another way to physically separate a mixture is through distillation, right? And distillation relies upon different boiling points. So one way that we can make distilled water, pure water, is to use distillation. Evaporation also. One way that they can make salt is they allow salt water to evaporate and the salt's left behind, and they can collect that salt and use it, commercially sell that salt. All right, but distillation. Okay, so in distillation, they take salt water and they boil it. Now, the water has a lower boiling point, and so it boils first, and it will boil into steam, and the salt will stay behind. So the steam goes into this condenser tube over here, and the condenser tube will have cold water in it, and the steam will go through that center part. So that cold water will cause that steam to condense, and then they collect the water, and this will be pure distilled water. When we mean pure distilled water, it means it is just H2O. Most samples of water will have minerals mixed in it. For example, it may be fresh water, but it's still going to have some minerals within it. Like the water that comes out of the tap is not pure distilled water. It'll have chlorine in it, it will have fluoride in it, it'll have some of the minerals that were in the river that it originally came from. All right, so there's several different types of mixture, and the different types are based on how evenly the substances are mixed together. Like for Kool-Aid, it's mixed together, you can't tell the different parts of it once it's mixed together. Or clean air is pure clean air would be you can't tell the different parts, and sometimes you can tell the different parts. All right, so when you cannot tell the different parts, it's mixed so evenly that you can't tell the different parts. That's called a homogeneous or homogeneous mixture. So, for example, like tea. Once it's really mixed together, you cannot distinguish the water from the tea that's dissolved in it or the sugar that's dissolved in it. Okay, so that's homogeneous mixture. Homo here, it means same. Just like you learned in biology for homozygous traits when they were the same um, alleles for those traits. Okay, so if it is a liquid homogeneous mixture, we often call it a solution. Um, all right, and you cannot tell a solution, cannot distinguish the different parts even under a microscope. All right, now solutions can be solids, liquid, or gases. Generally, we're talking about a liquid though, but they can be any of the others. All right, so like stainless steel is a homogeneous mixture. It is made up of iron, nickel, and chromium, right? And that's been melted down, right? It's been melted down, mixed together, and then allowed to solidify. And once it's solidified, you cannot tell the different parts. Bronze is another solid mixture, homogeneous mixture of copper and tin. Brass is copper, zinc, and lead. Right now, clean air. Clean air, not where the clouds are. That would be heterogeneous because you can tell the different parts. But where is this clean air? All right, that would be a homogeneous mixture. And you're made up of 78% nitrogen, 21% oxygen, and then 1% other gases like carbon dioxide and water vapor. Okay, so a heterogeneous mixture, you can tell the different parts with it, right? So for like sandy water, you can see the sand and you can see the water. Or orange juice, you can see the pulp within that orange juice. A salad is a mixture, and you can see the different parts. Or a pizza is an example of a heterogeneous mixture. Hetero means different. So remember heterozygous traits were when you had two different alleles, like a dominant and a recessive allele. All right, so within heterogeneous mixtures, there's two special ones. One is called a suspension, right? And in a suspension, it's a temporary heterogeneous mixture that separates into layers over time. So something like sandy water, or muddy water, if you allow that to set, then eventually the sand or the mud will settle down to the bottom, and then the water would be left up atop. Right now, a colloid is another special heterogeneous mixture. In this case, the particles don't separate out over time; they stay suspended. Right? And so, like milk is a colloid, and the fat globules and stuff in there stay suspended. And so, what happens is that when light is shown through a colloid, the particles are large enough that they'll scatter that light, and you'll be able to see the light within that heterogeneous mixture. Right? And that is called the Tyndall effect when you see that light beam. Right? So you often have seen the Tyndall effect without knowing that's what it's called. Whenever you see sunbeams, or here is light going through salt water, here you see the sunbeams. Fog lights are usually the most common example of the Tyndall effect. When you see those light beams in the fog, that's the Tyndall effect. And you can also see it in smoke. Usually, when I teach this, I do a demonstration and I light a piece of paper on fire and shine a laser light through it, and you can see the light through it. And that's called, again, once again, the Tyndall effect. Right? So that's the end. So just to recap, pure substance is always going to be the same, and it's only an element in a compound. A mixture um, is when things are just mixed together, not chemically combined. You have homogeneous mixture or homogeneous when you can't tell the different parts. Heterogeneous mixture, you can tell the different parts. Two special heterogeneous mixtures are suspensions and colloids. Suspensions settle over time. Colloids do not and will scatter light to create the Tyndall effect.